All right, folks, welcome back to Mike and Maurice's Mind Escape. We have episode number 133 today. Excuse me. We're going to be talking about Supervolcanoes Part 1, Yellowstone and Lake Toba. I know we've been teasing this episode for a while. Obviously, things have come up and there's a lot of stuff going on in the world, but we want to go over this and how these, what the scientists are saying, if Yellowstone is going to erupt at any time soon, that kind of stuff. People talk about it all the time when there's earthquakes and stuff like that. So I thought it would be a good episode to go over. And check out our new website at mindescapepodcast.com. We have everything on there. Also, check out our Patreon at patreon.com/mindescapepodcast. For $2 a month, you'll get exclusive content. And so now we're going to jump right into it.
Like we need anything else to worry about in today's age. Here we go.
Exactly. Well, and also, too, sorry for everybody that listens to us. We had a couple week hiatus there. Maurice didn't have power for a week, and then this last week I had some other stuff going on. So, but we are back.
Up and at 'em. We're going to be moving up, and that's about it. That's all I can say about that.
Good one.
We're moving on up.
All right. Here we go. Some terminology. So a supervolcano is a big volcano that has had an eruption with a volcanic explosivity index of 8, meaning that the volume of the deposits is over or at 1,000 cubic kilometers or higher. So, I mean, that's a massive amount of material.
That's large.
The volcanic explosivity index, or the VEI, is a relative measure of explosiveness of volcanic eruptions. Magma, most people have heard, is the molten natural material that forms igneous rocks. The layers of the earth, the basic, ones are the inner core, the outer core, the lower mantle, the upper mantle, and the crust. And then you got the subduction zone, which is a process that occurs when one tectonic plate moves under another tectonic plate and gravity forces it to sink. This process takes place at the convergent boundaries of tectonic plates, and the rate of subduction is measured in centimeters per year, so that might sound like a little, but I mean, over a long span of time, major shifts happening. So the average rate of convergence is roughly 2 to 8 centimeters per year along the boundary plates. So seismic waves of energy that travel through layers of the earth, causing earthquakes, volcanoes, magma movement, and landslides. Most people have heard of the Richter scale. In fact, today there was a massive earthquake in Mexico. I think it was like 7.5 or somewhere around there. The Richter scale was created in 1935 by Charles Richter, and it measures the strength of an earthquake and assigns numerical value based on the magnitude of it. Pyroclastic flow is a fast-moving current of volcanic matter and hot gas known as tephra. These flows can range in speed from 100 kilometers an hour to 700 kilometers an hour, which 700, I mean, that's pretty intense. The gas temperatures can reach roughly 1,800 degrees Fahrenheit. And there are, they're pretty common. I mean, most volcanoes have this if it's an explosive eruption, and it definitely has devastating results. Once the flow touches the ground, it hurtles downhill or spreads laterally under gravity, which is kind of interesting. A caldera is a volcanic depression that is formed by the collapse of the ground above the magma chamber, and that empties during a large volcanic eruption. Okay. There will be some other stuff, I'm sure, too, but we'll just try and cover it as much as we can when we get in there. So here's a map highlighting the subduction zones, and you can see how the one from the west coast of Australia, the east coast of Australia to the west coast of South America and up by Alaska and along there. That's called the Ring of Fire, and goes down around Asia.
Mm-hmm.
And that's the area that super volcanic activity. So most of this stuff's happening around the Ring of Fire in the Pacific and all the way over to Indonesia and Asia.
The old Johnny Cash song.
Here's a here's a diagram showing you the different layers of the Earth. Like I said, in the terminology, the inner core is the very base, which goes into the outer core. The inner core solid, outer core liquid, and then it goes up to the mantle, the lower mantle, and then the upper mantle, and then you get going up towards the crust there. In terms of, I was reading something too. I was reading an article where it's saying that the core was growing because I forget the process that they were talking about, but I just thought that that was an interesting fact that obviously all these parts, under us, obviously we live on the crust, but everything going on under us is very intense, very high temperature, and constantly shifting, constantly moving. Here's an elevation histogram of the Earth's crust. So this would be as you can see, the very bottom there would be like by where the Mariana Trench or some deep sea place would be. And then the very high point that you can see there is where Mount Everest would be. And then the very top right corner there, that little red thing is a scale of the Eiffel Tower, just for reference. So as you can see, even the crust is pretty massive.
Yeah. Crazy. So
this is a diagram of the core and the movement of the core. As you can see, the spiraling, and this creates magnetic fields, which is, we've talked a lot about the electric universe stuff and magnetism and how that interacts with gravity and stuff. So it's pretty interesting to see what's going on in the interior there.
Does that stuff correlate with the Viola vertices, like the Bermuda Triangle?
I haven't connected this to. This one's more scientific. I haven't connected this to any sort of woo factor yet, but
well, I don't think it's woo factor. It's
no, but I mean those are. I know those are magnetic reference points, like ley lines and stuff like that. I'm not saying that it doesn't exist. I'm just saying I haven't connected any of this. I haven't gone through any of that. This is more just purely putting information out there because I hear people talk about supervolcanoes all the time and worry about it, but I don't ever see anybody look into it or put anything interesting out there. So
right. Well, I don't know if we're gonna get into it, but I know this. Well, we'll talk about that in a minute. Go ahead.
Here's the geological province map there. You can see the different layers of the different types of rock. What were you going to ask?
I was just going to say I was watching that BBC documentary, and they were talking about how the Yellowstone volcano has already erupted 3 times.
Oh, we're going to get into that. It's
okay,
it's actually erupted more than that. But yeah, that's
all right.
Good point. Maurice did a little bit of homework on this one.
Hey, you know what I'm saying?
So also anybody listening to this, I'm sorry, this is going to be a super visual episode. We do these sometimes. So if you're listening, go on to our YouTube channel, subscribe, check us out. All of our episodes are not only audio, but they are on YouTube. So if you're looking to look at the diagrams, take a gander on our YouTube page. So, all right, here we get to the volcanic explosivity index. As you can see there, there's on the left there, it's showing a diagram, as you can see, and it's got some of the notable eruptions on the right, and then the scale on the left. So the VEI is a relative measure of the explosiveness of volcanic eruptions. So it depends on how much it's the explosiveness of it. So maybe, there's different types of volcanoes. There's ones that have runny basaltic magma, which you would see maybe in like the Hawaiian Islands, where it's slow, it's not explosive, it's just creeping out of the it's just ejecting slowly, it's not anything crazy. So and the VEI was created in 1982 by Charles Newhall of the USGS, which the USGS is the US Geological Survey, and Stephen Self from the University of Hawaii. The VEI includes things like eruption and cloud height, the volume of product, and qualitative observations. The scale ranges from 0, which would be gentle, like I mentioned, just slow running magma coming out of the ground, and it goes all the way up to 8, which would be considered mega colossal. And some examples of mega colossal eruptions are Huckleberry Ridge Tuff, which is by Yellowstone, Yellowstone, and then you got Lake Toba, and you have Taupo. I think Taupo is in New Zealand. We're going to be talking about that in the future.
Okay.
Maybe part 2, or if we get to a part 3, I don't know. A list of the famous volcanoes, or here's a list of the famous volcanoes and their VEI numbers and where they rank on this diagram. So Kilauea would be 0 to 4. And
Well, let me interrupt you. Those 10 the highest?
No, 8's the highest.
Oh, okay. Alrighty.
Like I mentioned above.
Oh, well, hey, there you go.
Pay attention, good man. All right, so Kilauea has erupted like many times. So I just took, 0 to 4. So some of them have been 1, some of them have been very nominal, and others have gotten up to 4. Mount Vesuvius, which is a famous one, that was a 5 on the scale out of 8. And Mount Fuji was a 5. Mount St. Helens was a 5. Krakatoa was a 6. The Valleys, or I don't even know how you pronounce it, Valleys, Caldera is a 7. Thera is a 7. That's in Greece. Most people, or there's some people that correlate it to possibly Atlantis because it erupted, I think, 1600 BC, and it definitely had a major impact on ancient Greece culture and the seafaring people. And it's right by Santorini, so, or pretty much is. Taupo is a 7, as I mentioned before. Huckleberry Ridge Tuff, that is 8. And Yellowstone is an 8. And Lake Toba is an 8. And a Taupo not only has a 7, but it has an 8. So watch out if you're, over in that area. Again, I think the Taupo one, I'd have to look it up again, but I'm pretty sure it's in New Zealand or around that area. Some critics of the VEI point to the fact that ash, lava bombs, and ignimbrite are lumped in together, and the density is not figured into that. So it also does not take into account the power of the output, which makes it tough to determine an accurate VEI for prehistoric and unobserved eruptions. So obviously, throughout history, people know these crazy eruptions happened. You can see the effects on some ancient civilizations, but in terms of having the knowledge that we have now or the tools to record these things, it was obviously a lot different back then. So I think a lot of this is based on, people's accounts or reimaginings based on data or geological data. So,
yeah, and Taupo is a town in the northern island of New Zealand.
There you go. Good one. Young Jamie finally becoming young Jamie.
I'm old Jamie at this point.
Okay, so Yellowstone Park, as you can see there, which is pictured. So you have, as you mentioned, it's erupted a few times. So, and there's actually new evidence that they found that we'll get into in a minute. But so you have the first caldera, which is the light. It's like a lightish blue, and that erupted 2.1 million years ago, and had an ejecta volume of 600 cubic miles, which is crazy.
Yeah, that's a monster little zone there, it looks like.
Yeah, and even goes underneath the resurgent dome and the third caldera. So that's the first one, and then you get to the second caldera, which is 1.3 million years old. And that one is a lot smaller, and even the ejecta volume, you can see it's 67 cubic miles, which is not as crazy. The third caldera, as you can see, overlapping the first caldera, and then it also has Mallard Lake Resurgent Dome and the Sour Creek Resurgent Dome. Those that caldera had an ejecta of 240. So. And then you do have a fourth one there, if you can see in the red, the West Thumb Caldera, and that erupted, I think, 174,000 years ago. But that wasn't an explosive, if I'm not mistaken. I think it was just kind of a light flow compared to the other ones. So there we go with that. All right, so here's a diagram of what's going on underneath the surface at the Yellowstone Caldera. And we'll get to the size of the Yellowstone Caldera. It's massive. I mean, I'm shocked. Like when you picture a volcano, yeah, you know they're big, you know the caldera's big, whatever. But when you look at these supervolcanoes, since they're like lower setting to the ground, they're absolutely just massive. So you at the top there, you have the rim boundary fault, and you have the geysers. Obviously, Yellowstone's known for its the geothermal activity and the geysers and all that stuff. So what happens is you have the magma chamber or the partial melt, and it heats the ground up underneath, and then you've got all these systems, this geothermal activity, and the magma underneath heats it up, and then you have the geysers and all that kind of stuff. That's why people go to Yellowstone, or one of the reasons why, is you have all that cool activity. And yeah, so you have any questions?
No.
Okay. Yeah, it's a pretty explaining diagram there. There's no reason to go through the whole thing, but I just wanted to point that out about the geothermal activity and the way that the magma chamber heats it up underneath. Moving on.
Yeah, and the caldera is like when the ground crumbles.
Caldera.
Caldera. Right? It's like when the ground crumbles over it because of the Earth's because of the heat coming out of it or whatever.
Yeah. So I mean, the caldera is what's caused by. So there's the magma shoots up there. I don't think they're 100% sure exactly why these eruptions take place yet. I've read a few different things. There's suggestions of what's happening, but the magma shoots up explosively and blows out these huge portions of where this hot spot is. And we'll start talking about hot spots in a minute, but there's not like a mountain and then it just blows up or anything like you see like in movies or on TV. It's something shooting to the surface, and that just so happens to blow out all this material, and that's and then you get the caldera afterwards. That's the leftover remnants. The Yellowstone Caldera is a supervolcano and volcanic caldera. Caldera. I don't even know. I mean, whoever, you take it either way. Tomato.
Leave a comment below, and we'll take your advice.
Is located within the Yellowstone National Park. The caldera or caldera. And a large
I think it's caldera. I'm pretty sure
I think it's caldera too. The caldera and the large portion of Yellowstone Park are located in the northwest corner of Wyoming. So the caldera is located, the one at Yellowstone, the ones that we just showed, most of those overlap in the corner of the northwest corner of Wyoming. But the hotspot traveled, I think, from Oregon all the way east on like an upward swinging pattern through the bottom of Idaho into the northwest corner of Wyoming. The caldera and a large portion of Yellowstone. Oh, I already said that. Okay. The main part of the caldera is roughly 35 by 45 miles. So, I mean, that's pretty big.
Oh, yeah. That's massive.
Yeah.
And that's just the caldera. What's underneath that is,
right.
They said, what is it, like 3 or 4 times the size of New York City?
Yeah, it's crazy.
Yeah.
Yellowstone sits on 4 overlapping calderas. That's what we just mentioned. The first caldera, 2.1 million years ago, and had an ejecta. Again, we mentioned this, 600 cubic miles. The second one, 1.3 million years. And then the third one, 640,000 years. And then, again, the fourth one, which was not really explosive.
Right. Which makes sense because back the older the Earth was, the more of the volcanic activity that was going on.
Well, I don't think though. We'll talk about what you're saying. I think that that's the common thought when you think about like the evolution of the Earth. Oh, it was violent and volcanoes, and then everything settled down, and then we start to evolve. That's not really the case. There has been these periods of these cataclysms
Cataclysms.
happen, yeah, and supervolcanoes and stuff like that. Um,
Well, if you look at the numbers, it doesn't even really it doesn't support what I'm saying really, because the first one was 600, and the second one was 67, and then the one after that was bigger.
right.
So it's like back
You,
and forth almost.
yeah, you have to look at the data. But yeah, it's more about where the hotspot is underneath, or like what's on top of the hotspot, like what kind of material is you know what I'm saying? And we'll talk about why in a minute. But
Yeah.
let's go to the next slide. Okay. This area has been active for over 18 million years, creating violent eruptions and less violent basaltic lava flows and floods. Roughly 12 eruptions in this area helped shape the eastern part of the Snake River Plain, which was once a mountainous region. So if you look at the Snake River Plain, obviously it's this big cutout thing, and they're saying that Yellowstone had a hand in shaping the eastern part of that through eruptions. So
Yeah, if anyone's familiar with Ansel Adams, the Snake River is that one classic. I actually emulated that when I was in Colorado, but it's one of his most famous works. It's that snaking river. It's right into the Tetons. It's really beautiful there.
yeah. Yeah, you haven't been there, but you've been out west near there a couple times.
We were planning on going to do the Tetons this year, but my cousin's getting old and he wants to do this harder trip first when he's as young as he can possibly be.
I thought you should have gone back to Glacier, even though he's been there. That's the best pictures. There's some lake there that people take pictures of. It's like all the different
Yep.
pebbles are different colors or something. And people get the shot where you get the mountain doubling off the glassy lake. You know, that's a sick shot. Okay. Where were we? Okay, so Yellowstone had an non-explosive lava eruption. I don't know why I put lave. It's lava, and less explosive eruptions since the last super volcano eruption. So again, even if Yellowstone was to erupt again, you would have. I mean, it's not guaranteed it would be a super eruption because it depends on how much magma, what the melt is. There's like a lot of factors that play into it. So it's not just as simple as, oh, the magma chamber is ready to blow. And even if it does start to rise, you know, the resurgent dome and things start to build up, it could be another flow again. So again, there's a lot of different factors that play into this. So
Are we going to get into some of the solutions at the end?
yeah. Oh yeah.
Okay.
We're going to talk about everything. The tectonic and volcanic activity in the region caused between 1 to 2,000 measurable earthquakes a year. So, I mean, that's a lot. But
Yeah.
not all of them.
A lot of them are really small, though.
Yeah, exactly. Not all of them are huge. So, in December of 2008, over a couple months, there was over 500 earthquakes, with the largest recording at a 3.9 on the Richter scale. There was also volcanic swarms in 2010, 2014, and 2018. So, you know, there is stuff happening there. It is active, but you expect that area to be active. It's not like it's unknown that it's that active. So, basically, some studies show that the hydrothermal explosions can occur independently from eruptions that may even be more of an imminent hazard. So, in the last 14,000 years, 20 lake craters have been formed, creating lakes, bays, and ponds. In 2016, the U.S. Geological Survey announced that they were going to map these subterranean geothermal systems. So, this is saying there could be one of these massive geothermal events too. It's not just a volcano. There could be some sort of, you know, lake forming event or something along those lines with, you know, the activity that's going on there.
Well, that's what I'm hoping for. Some more landscapes to take pictures of.
And history shift, I see your messages. We'll get to some of those here in a minute as part of the slideshow. Okay, so this is a recent article that came out. I saw it. I didn't even think anything of it. I just thought it was like our buddy Martin sent me the article, and I read through it, and then I looked up the scientific paper online, which I'll add all these links to. I'll add some articles and some links down below the video when we're done. But so I read the scientific paper, and we'll get into that here. So the hot spot under Yellowstone has migrated over time from southeast Oregon through Idaho to the northwest corner of Wyoming. So where it's important to note that it's where the hot spot is where this is going to happen, if it's going to happen. And I'll pull up a map after I get off this slide of these hot spots so you can see the movement. But to your point, history shift, you were asking about, is it going to blow like it did before? Again, it depends on what the material is above the hot spot, and if the crust is thinner, if it's thicker. This article will highlight, and we'll get into it now, but the more inward the hot spot moves, the thicker the continental crust is, the harder it would be for there to be a super eruption. So the hypothesis is that the more inward it moves, the less explosive it becomes. So, and I'll tell you why now. So Thomas Arnott is a geochemist at the University of Leicester, and his team used paleomagnetic analysis because the iron that was ejected would have been liquid and then would have settled and cooled towards magnetic north. So they're saying that all the iron that's ejected, that's molten, would have settled towards magnetic north, obviously, because it's magnetic. Knott said since Yellowstone supereruption would have slightly been different, it would have had slightly different chemical profiles because of the different sections of the continent that are being melted. So that's the point I was just mentioning. It all depends on what's above, what's the material above, and that's how it affects, is it a thicker crust, thinner crust, what's going on? That
it's matter. Like pizza.
I guess. If there was,
sorry, I got to inject a little humor in this whole thing.
If you were cooking a pizza on top of a magma chamber, yeah.
Hey man, that might be the new way to do it.
It was originally thought that there were a bunch of smaller eruptions in southern Idaho. However, Knott's recent hypothesis and study says that evidence suggests 2 super eruptions, including one top 5 eruption of all time at Gray's Landing in southern Idaho. McMullen Creek was one of the super eruption locations, and that was dated to 8.99 million years ago, and it covered over 4,600 square miles stretch. That's massive, and it's in southern Idaho. And it registered an 8.6 on the VEI index. So that's pretty big. I mean,
wow.
8.6, it only goes up to 8.9. So that's if something's going above 8.9, and we're here to record it, we won't be here long. So
you lied to us. You said it went to 8.
It goes to 8.9.
Don't pull that over on me,
okay,
bro.
so they're getting specific with it. This is new data.
Yeah.
This is what I'm saying. This one that they supposedly found in southern Idaho, because it's so old. It's the ones we were talking about at Yellowstone, the 3 main ones. Those are starting 2 million years ago. This is going all the way back to almost 9 million years ago.
And how do you even measure something that old? Are they using rock?
Yeah, they go through the layers of the rocks, and geology is one of those things where it's right in front of you. You don't have to. You're not looking at nanoparticles through a microscope and trying to figure out different analysis on it's even though you have the hard sciences and then you have the humanities and different things, geology is probably one of the hard sciences where, again, it's right in front of you. There's evidence there. Now you could go back and forth with the exact dating on certain things, but I think they have a general idea of what's going on.
Okay.
So Gray's Landing, the one I mentioned, super eruption was dated to 8.72 million years ago. It covered 8,900 square mile area in southern Idaho and northern Nevada. It registered an 8.8 on the VEI and is rated as one of the top 5 eruptions of all time. The VEI, again, only goes up to 8.9. So this one was one below the highest it could be on the scale.
So what happens if if something happens that's bigger than that? Are they just going to put it at 8.9?
Say that again?
Like, never mind.
So if you're saying, okay, so if there's something larger than an 8.9, we're dead.
Hey!
And if
All
if
right,
we're
that
not
makes sense.
immediately dead from living in the U.S. somewhat close to the supervolcano, we would be dead because when we get to Lake Toba, you'll see, the fallout of these things could, be a volcanic winter where you'll see.
Right.
Some geologists. So this hypothesis obviously is not set in stone. We talk about this all the time. You have speculation, then you have hypothesis, then you have theories. A theory is a hypothesis that you can replicate again and again and again. In terms of this, from what I read on different articles and different people's interpretations, some geologists agree with the findings and suggest that we still don't know the cause of magnetic flare-ups, especially over hotspots, which I was mentioning. They don't know the exact mechanism for which this volcanic explosiveness happens. But the U.S. Geological Survey has a geologist named Michael Pollan that said it would make sense that Yellowstone hotspot would weaken as it migrates inwards towards the thicker crust of the continent. Still, other scientists suggest that all this only makes sense if you look at the largest eruptions, even though there are other super colossal eruptions that are also very dangerous. So some are saying we don't know the exact mechanism for this. Some are saying that this is only looking at part of the data, only the largest of the eruptions. So, take it for what you will. It's an evolving picture.
Is that eruption that happened, the oldest one? Is that the largest eruption that we know about ever?
It's the one that you're talking about. It's the second oldest one. The oldest one we know. I don't even know if it's the oldest one that we know, but this is just from this specific hotspot pattern.
Okay.
So I didn't go into the complete history. I don't know, maybe even 100 million. I don't know what they know in terms of that. How far back it goes. But this is just this is just
the theory of
pertaining
the dinosaurs.
Well, I think it's been pretty proven with the asteroid impact crater in the Yucatan, that's what did them in.
I thought it was a combination of a couple of things.
Could be a lot. Yeah, that's actually a good point. It could have been. Okay, so if a comet or an asteroid hit the Yucatan and blew this thing out and started to kill, you have a fallout winter, and you've got all this stuff happening. I could see that maybe even the impact would have such an effect on the crust that maybe it does set off some super eruptions. I'm not a scientist, I'm not a geologist, but I don't see why that couldn't be the case, or at least, I don't know. That's part of the picture, but yeah, that's a good point. I think you could probably look into that. Okay, so here's the hotspot pattern that I was talking about. So you have it starting down there. See the 6.1. You're over more towards Oregon, and then it gets the 15, and then the 12, the 10, the 10 to 7, 10 to 7. It's moving up through southern Idaho, and then you get to the northwest corner of Wyoming, where everything is today. That's where the hot spot's moving. And again, people are just listening. The hot spot is what controls what gets molten and possibly a supervolcano. Is Yellowstone due for an eruption? According to the U.S. Geological Survey, no, it is not due for an eruption, nor is one imminent. Volcanoes are unpredictable, and most volcanic systems that have had supereruptions do not have them again. Yellowstone is unique in that it has had three. The first was, again, 2.08 million years ago, second one 1.3 million years ago, and the third 631,000 years ago. The average time between supereruptions is about 725,000 years, which puts us about 100,000 years away but that doesn't mean it's going to erupt anytime soon, or even when 100,000 years passes, it's not guaranteed that it's going to happen. So,
Right.
people that are worried about it, I don't think you should worry about it. I think let's say you live to 100 years tops, or
Yeah.
let's just say you live 120 years. You're fine, in my opinion, unless some crazy stuff happens and then the resurgent dome starts to go crazy and all of a sudden the magma's building and building and building. I would say not to worry about it. Like I mentioned before, a smaller lava flow with no explosivity or a geothermal event is actually more likely to happen, which both are not great either, but at least it's not,
Well, people that are nervous about, what the humans are doing to the Earth may have a hypothesis saying that we're doing things that may
No. Okay,
cause
so
stuff to happen quicker.
but this is different. I mean, this is internal. This is not external. What we're doing to the Earth is primarily, I mean, yeah, you could say we're having an effect on the atmosphere and the environment and all that stuff, but the thing that's moving everything, the core, the mantle, and then, you've got the magma and all that stuff. I mean, that stuff will just crush garbage. So, I mean, that's not even
I worry.
well, it's a worry for us.
Well, you can worry about anything. Humans
Well, I mean,
love to
but
worry.
that's a worry for us because we live on the crust. This is all happening internally. So
Right.
I don't think that, if anything, actually, I read an article saying that there was more seismic activity from human beings not being active because of all this lockdown stuff. If that makes sense.
That's a good point. Yeah.
So I don't know. I mean, it was all micro scale, but I think when the thing first, when this stuff started to happen, I remember seeing, I think Yellowstone had a 5 or a 6 on the Richter scale earthquake in Idaho that people were worried about because it's so close to Yellowstone. But the geologists came out and they said, yeah, this happens once in a while. It's not a big deal. Even if, let's just say, a serious, like a 9 or something on the Richter scale happened, I mean, yeah, it would probably be a little bit nerve-wracking. But again, I don't think it's more due to this magma being ejected and having the melt be over 50%, which normal, I think, is like 10%. So, that's what we'll talk about right now. So the rhyolite magma, which is what's under Yellowstone, it's only 5 to 15% molten right now, based on their estimations. It would need to be 50% melt, and when I say melt, that means the it means stuff that's melted in there. It's not like hardened or semi-hardened. It's completely molted. It said it would need to be 50% melt for an eruption, and the average is about 10. So Yellowstone has erupted both basalt and rhyolite in the past. Rhyolite is an extrusive igneous rock that has a high silica content, and basalt is an extrusive igneous rock, which is rich in magnesium and iron and is formed from rapid cooling. So rhyolite partial melt is located in the upper crust and under the Yellowstone Caldera, and produces the hydrothermal fluids that we all think is amazing. Below that is the basaltic partial melt in the lower part of the crust that is 4 to 5 times larger than the rhyolite melt chamber. It also provides heat for the shallower rhyolite melt, and it stretches from underneath part of the Yellowstone Caldera to the edge of the eastern Snake River Plain. So... Why are there so many earthquakes at Yellowstone? Most of the earthquakes at Yellowstone are a result of rocks breaking caused by crustal stresses called brittle failure events. So the rocks breaking underneath is what causes all the seismic activity. No one has ever observed or identified long period events which is connected to the movement of magma. So at Yellowstone, for there to be an eruption or something, or seen movement there, you would have to see like long, sustained periods of this intense movement of magma for it to be kind of a threat, which they have never done. Even if there was a long period event, that does not mean that there will be an eruption. So even if there is sustained seismic activity or geothermal activity, it doesn't necessarily mean that there's going to be an imminent eruption.
It almost seems like it's the opposite when when it's happening all the time. It seems like they're dispersing themselves. But maybe that's just my opinion, my view. Mm-hmm. I'm no scientist, ladies and gentlemen.
Ground shaking or tremors are observed near the geothermal areas when the water boils in a geyser. All right.
Yeah, like Old Faithful and stuff.
Yep. You got it. Yellowstone interesting facts. So Yellowstone is roughly 3,400 square miles of wilderness. It contains hot springs and geysers. Geologist Bob Christensen has done a lot of research on the topic of supervolcanoes and geology. He's done a couple of the documentaries on YouTube, and I've read some articles out there about his research. There is tons of heat below Yellowstone, 30 times more than anywhere in the Rockies. Well, that's kind of interesting. August 17th, 1959, a massive landslide at Hebgen Lake killed 28 campers, and 19 were never found. It's the deadliest earthquake since 1933.
Well, if 19 were never found, wouldn't they be...
They're dead, yeah.
Yeah. I'm going to go out on a limb here.
Yeah. Yellowstone had an average of 25 earthquakes a week. That's second only to California. Yellowstone, a super eruption could produce 250 cubic miles of ash. That's enough material to bury Texas under 5 feet of ash. Just think about that. That's crazy.
Yeah.
The Yellowstone Caldera is so large that the whole thing can't even be seen from air.
Jesus.
Or from the air. So think about that. So even if you're like in a helicopter hovering over it, you still couldn't see the whole thing, which is just insane.
Yeah.
In the 1970s, geologist Bob Smith surveyed the Yellowstone landscape. He noticed a change at the south end of the caldera. It was 18 inches off the survey that was done from 1923. The caldera had risen over 2 feet, and in 1995, in the year 2000, it actually started to recede and go back down. So there is movement. It does go up. It does go down, but... there is evidence that Yellowstone Lake was inhabited seasonally by the Native Americans or Clovis people starting around 11,000 years ago. The rising and receding of the lakeshore revealed arrowheads and archaeological sites. So this is interesting. They've done some archaeological stuff around there, and they found Clovis, tools, which are like arrowheads and different spear points and stuff like that. And they're saying that during the summer months or the warmer months that the people would go there, maybe hunt and live around the lake, and that was only revealed when the lake, I guess, receded and they found arrowheads and archaeological sites along the shore. So yeah, we could talk about that at some point, but not on this episode. All right. Here's the Snake River Plain that I was mentioning, and how Yellowstone carved out the eastern portion of it. As you can see there, the top right, you have the Yellowstone Plateau, and then you see it cut out down towards that island park caldera. So again, these are powerful things. I mean, when you look at volcanoes, it could even be life giver. We talked about on our panspermia and abiogenesis episode. They think that hydrothermal vents underneath the water might be responsible for creating the building blocks of life. And
yeah, there's a lot of microorganisms. Like, we only know like 2 or 3%. I was watching a little documentary on that.
Yeah.
Because then they're going into like the lava and the extreme heat.
Yeah, they're called
heated.
They're called extremophiles. So it would be like a tardigrade. Most people know the water bear or the tardigrades, and recently there was an article that tardigrades dehydrate themselves, and that's how they're able to live through all these crazy cataclysmic events. Is they dehydrate, and then once they get moisture again, they rehydrate. So it's kind of crazy.
Yeah.
And they found some extremophiles living in literally pools of acid in different parts of the earth too. So what if Yellowstone did erupt? So while, as we mentioned, it's not imminent, and actually if you were to look at the average based on time of the last eruptions, like I said, we'd still be about 100,000 years off if you took the average, which that's not how this works. But if it did work that way, we're still a long ways away, but it should definitely be thought about, because you should have a plan. What are you going to do? Kind of a thing. I mean, if you're near there, you're screwed. That's just unfortunate, but that could, that happens all over the world, from hurricanes to earthquakes to tornadoes, you name it. We're living on a tough shell here, but
Oh yeah.
okay, so the type of explosive magma that is under the Yellowstone Caldera is comprised of silica and gas, which makes it a supervolcano. So it's the things that make it, that the material that makes it up is what makes it explosive or not. So if it's just a basaltic flow, yeah, it's not going to do much. But if there's gas and there's silica and there's all sorts of stuff trapped in there, it could be a recipe for disaster. The chamber must contain at least 50% melt for the eruption to occur. The average stable level of melt is 10%. So, what would, if it were to erupt, hypothetically, this is what you would see. Swarms of earthquakes would plague the area. A long continuous vibration or harmonic tremor would be the last warning. So there would be some sort of some people, hear weird sounds. I know we've talked about weird sounds that people hear different parts of the world where they live. There's even one in Windsor, which we've talked about a little bit before. But this humming would be loud. It would be noticeable. You probably think something crazy was going to happen, or God was going to descend from heaven or something. But
Right. Well, the Indians would have.
And even if you're not religious, you would definitely probably be praying at that point. So
Yeah.
Swarm. Okay, so yeah, we mentioned that. So that would be the last warning. That noise, which would be, I would assume, from the seismic activity, and the eruption would be 50 times larger than the largest atomic bomb. So just think about that. The explosivity of the eruption would be 50 times larger than the largest atomic bomb. That's crazy. A 60-mile radius would instantly be hazardous. There would be possible destruction up to 200 miles away. Pyroclastic flows reaching 1,500 degrees would flatten and scorch the surrounding areas. At night, you could see the pyroclastic flows since they're iridescent. It would engulf Jackson Hole. Most people and animals would suffocate in the flows. The mother of all ash clouds and deadly debris would shoot 15 miles into the atmosphere. The skies would turn dark and deadly. Wet ash would clog filters and collapse roofs. You wouldn't be able to drive your car through that. It would get shut down. And roofs would collapse and all sorts of damage. Swirling ash might induce intense lightning storms. You would see Salt Lake City and Denver would get ash up to 3 feet, which is crazy. Ash would cause mud flows and damage. People will panic and lawlessness will ensue, and which would make the current situation even worse. 500,000 people could die. Inhaling volcanic ash is basically glass in shards, and anyone who does survive would potentially have long-lasting severe lung issues. No one within 1,000 miles would be safe and could develop Marie's disease. Marie's disease is a disease where I believe from the stuff you're inhaling, your bones get denser, thicker, something along. I don't know exactly what it is. The what you want to call it, but it does something to your bones. They found it out because they found animals that have like crazy bone densities that died from like, I don't know, like lung issues and stuff like that. So Gases might stay in the air, affecting air quality and the atmosphere. Look up Marie's disease real quick, if you will.
All right.
I just want to make sure. I'm pretty sure that's what it is, but I just want to verify. In 1816 or 1817, there was a famine from cold weather caused by a volcanic eruption. In 1815, in Tambora near Java, 10,000 miles away, people were affected. Sulfur dioxide, sulfuric acid, aerosol, and this was all spread by stratospheric winds. Tambora killed 71,000 people. Okay, so a volcanic eruption that happened in 1815 near Java killed people all the way across the world a year later from cold weather and famine. Again, it's the fallout and some of these things you have to watch for. Yeah, the people in the immediate area will be affected, but you have to think about what it's going to do to the atmosphere, what's going to do to food sources, supplies, what kind of air quality is there. I mean, there's a lot of things to think about. So,
All right. Marie's disease is like ankylosing spondylitis.
yeah.
So it's like a type of arthritis in which is long-term inflammation of the joints and spine.
Okay. So, yeah, but they were saying that so much, it added so much bone density that these animals couldn't even move anymore. So, I mean, I don't know if that can happen in humans too, but.
Yeah, I'm sure it could.
Yellowstone eruption would cause a drop in temperature of roughly 10 degrees Celsius. That's crazy.
That's a problem.
All right, so that was Yellowstone. Okay, I do want to mention this. So I'm not the type of person to talk about problems or catastrophes and not look for some sort of solution or some sort of way to figure out if there's a way to dampen the blow, if you will. I know JPL and NASA have looked into possible fixes if this were to happen. And one of the things that was suggested was injecting water into the magma chamber to cool it down or to harden it to prevent, to melt to the point where it could eject. But there's a lot of people that don't think that's possible or would even work. Another possible solution to this was they talked about drilling little holes and letting some of the gases and magma out. But again, to get that deep, it's that hot. Again, people don't think that's possible either. So from everything I've read, with the technology we have, it might be more realistic to deflect an asteroid or a comet than it would be to stop the supervolcano.
Yeah, I mean, it seems like we're spending a lot more money in space excavation than stuff that's going on in our own world, like the seas and the volcanoes and things like that.
We are spending a lot of money on space, and we do have some ideas. Like one of the theories to deflect one of these asteroids or whatever would be to use light, because the way that the asteroid or whatever tumbles through space, if you could use, it's called like a light sail, and the light sail would push it off of its course enough where it would miss us. So we have cool ideas when it comes to like deflecting, or even people have talked about blowing up, asteroids or comets or whatever. But in reality, we're living next to a ticking time bomb that we have no idea whether it's going to go off, when it's going to go off. I mean, I'm not trying to freak people out. Obviously, that's not. I've just presented a lot of evidence to the contrary that we should be fine and that it's not an imminent threat. But you do have to think about the alternative, and if the top minds are thinking of things and what they're thinking isn't necessarily going to work, I think that maybe some more money should go into that kind of stuff to prevent future cataclysms. So
right. But when people hear, oh, it's going to happen again, it's like, okay. But then if you look at 100,000 years, that's a long time. So how long have humans been intelligent? It's a tiny little piece of that. So we'll see what happens.
I mean, yeah. I mean, humans have been humans, or Homo sapiens have been Homo sapiens since for 200,000 years ish. So
call Ben Affleck, bro.
All right. Somebody just commented, "Can't we just nuke the volcanoes?" Yeah, I mean, at that point, we might want to do it to ourselves and just end it, because there'll be a lot of suffering afterwards. That's for sure.
I've heard about people talking about that, like dropping some kind of bomb on it. I mean, you'd have to obviously.
I mean, okay, so realistically, is that? I mean, I'm sure nothing. When it comes to this kind of stuff, I don't think anything's off the table. I don't know what kind of reaction that would be. Meaning that it's already explosive. Okay, so if the explosions I just mentioned would be 50 times an atomic bomb, so would you want to add more explosivity to that mixture? I don't know, but
yeah.
So I don't know, just a thought. But
Where you shoot at something, you don't know what's gonna happen.
yeah, I mean, again, I think the one that I liked was the JPL NASA one, where they talked about potentially injecting water to cool down the magma so it won't shoot out. But I mean, I don't know.
You need tools that can withstand the heat.
Yeah, I mean that's going to take a lot more ingenuity on that end to figure that out. So
And maybe the money we're dumping into NASA could help with that, but
yeah,
I don't know.
All right, so now we're moving on to Lake Toba. So that was Yellowstone. We spent a lot of time on Yellowstone. Yellowstone has a lot of data because of the U.S. Geological Survey, and I wanted to focus on that because it's, not that far from where we live, and it could definitely affect us if that were ever to happen. So, and from what I mentioned, even if you aren't in the immediate radius of this thing, the fallout would affect the whole world. So,
Mm-hmm.
all right. So Lake Toba. So there you see Lake Toba, the little arrow pointing to it. It's on Sumatra, and it's part of Indonesia.
Beautiful area.
Yeah. There you can see I highlighted. So Lake Toba is the lake part, and then you see the resurgent dome in the middle, which is actually an island now. It's called Samosir. So that whole the dome, the resurgent dome, is where it's the lava or the magma chamber is pushing that up. So that got pushed up over time. That little island thing, when it first erupted, that wouldn't have been there. That little island.
Mm-hmm.
So
How's that lake? Is it inhabitable, or is it just super hot water and acidic?
that's a good question. I actually didn't look into that. You can
Let me take a peek
you can
here.
look into that. That's a good question. Probably your best question yet, pal.
Wow, this guy's getting smart.
Okay, so Lake Toba is a natural lake that formed in the caldera of a supervolcano. The surface elevation is just under 3,000 feet, and it is 62 miles long and 19 miles wide. It is the largest lake in Indonesia, and it is the largest volcanic lake in the world. Lake Toba registered an 8 on the VEI index. Okay, so you were talking. You asked about the explosivity index. You said it only goes to 8. Well,
Yeah.
we have no idea exactly what Lake Toba was, but they put it as an 8. But maybe it's obviously was more devastating to human beings because, for instance, if those ones in southern Idaho happened 8.9 million years ago and 8.72 million years ago, we were obviously different. We were a different species back then. And to the point of this Lake Toba thing, Lake Toba had such an impact on humanity and the world. I think we'll talk about it, but for being as recent as it's the most recent explosive event, but we have no way of telling. I would imagine that it's at least an 8. Maybe it even goes up way higher than that, but that's just what the evidence calls for at this point. It was the largest explosive eruption in the last 25 million years. It erupted 74,000 years ago. So there's estimates. Some put it at late, like 68, 69,000. Some put it at 77,000, but more conclusive data suggest a 74,000 year dating, killing most of the humans at the time, and genetic evidence that human evolution went through a bottleneck. So they know through genetic tracing and different things that there was this bottleneck that happened from this event. So a few to 10,000 breeding humans survived based on the migration evidence. So that's nothing. So like 3,000 to 10,000 people are, I mean, think about that. Think about everybody getting wiped out on the earth except for a few thousand people. It's just insane.
Yeah.
Lake Toba led to a volcanic winter worldwide, causing a drop in temperature between 5 and 10 degrees Fahrenheit. And in the higher latitudes, 27 degrees Fahrenheit. That's crazy. People, we're worried about 2 degrees with all this, environmental stuff. And then you have one of these events that can cause a 27-degree shift overnight. It's crazy.
Right. Well, the humans like to think that we're big and bad, but when it comes to nature, that's big and bad.
Mother Earth, yeah, it'll.
Yeah. I wanted to interject real quick here too. Yeah, it's highly inhabitable. There's tons of fish and all kinds of stuff. I'm looking at a picture. This place looks sick.
Yeah. Well, I'll pull up pictures in a second. This thing will blow your mind. You'll want to go there to get some.
I'm actually booking my plane ticket right now.
So Lake Toba was the last in 4 caldera forming eruptions. So again, you saw the hotspot diagram for Yellowstone. That when the hotspot moves, you see the kind of action that leads to this kind of stuff, and it's gradual, and it depends on what kind of layers of crust and what's in the layers and that kind of stuff. Some parts of the caldera show that the magma chamber is refilling, which is why you see Samosir Island and Uluan Peninsula above the surface of the lake. So again, I'll pull up a picture in a minute, but you saw the lake, and then you saw the resurgent dome, which is also this little island, and that wasn't always there. Again, that got pushed up via the magma chamber over time. Lake Toba is near the Great Sumatran Fault and the Sumatra Fracture Zone. Large earthquakes have happened near there, one in 1892, one in 1916, one in 1920, and one in 1987.
So we're due, people. We're always due.
If that okay, so here you can see that's Samosir, that island. That's the resurgent dome. So that's the magma that's underneath there that's pushed this thing slowly up over time and produced what you see there is an island. And
Hawaii, that's like pretty much Hawaii is all stuff like that, right?
Yeah. Well, different in the sense it's not a supervolcano.
Right, but it's all.
But the volcanic activity, yes, does have an effect on the Hawaiian Islands. Here's another different style map so you can take a look at it. It's fascinating to think that we have all these different things that could affect us at all times, and we always all sweat the small stuff, but really there's these crazy events that are just a tweak of a crust here or a tweak of a crust there from happening.
Well, I already have anxiety, so thanks, man.
There's a shot of the lake in Samosir Island from the sky, from a plane.
Yeah, it'd be cool to do a little documentary on some of these supervolcanoes. Yeah, that's nice.
That's a great shot too.
I'm sure it's a drone or something. I don't think there's something up. Unless there's a mountain that high.
Yeah, we'll look at the mountains in the background. You could just be on a higher peak.
Right. It's nice though. It's the island in the middle.
See, there you go. There
says the people inhabit it. That's sick.
So we just commented, my anxiety has anxiety.
Well, my nickname is Dr. Anxiety, so I'm getting help with that.
Look at that.
I don't know.
Pan shot right there. That's awesome.
Right. I mean, I'm pretty sure these are shot from a helicopter.
That's a pretty sick shot to get if we're in a helicopter.
Yeah, I was watching a little documentary on this guy that works for National Geographic. This is before drones or any of that stuff, but yeah, he's like, if you can afford it, wherever you go, charter a plane because the shots you're gonna get are just so much better than the stuff that people don't get.
Yeah.
Obviously, chartering a plane isn't that cheap, and he's getting paid by National Geographic, but you
Right.
just get stuff like that. Again, with drones nowadays, which a lot of the areas they're illegal or you have to like register them, but
Yeah, you have to get like
yeah.
I know you by us. I think you have to get permission like to use it or something. Because
Yeah, depending on the weight
people
of
even
them.
use it to take like drone shots of their houses and stuff when they're trying to sell them.
Yeah, yep.
And that's it.
Boom.
That
And
could
then
be
we'll end with a scary little thing
well.
here.
Here's something I will say that is inevitable. That's going to happen again. It's going to happen many times throughout the Earth's history. You can't stop it. This is just how the planet works. There's ebbs and flows, and there's shifts, and you've got the hot spots moving under thinner crust, potentially being exposed to explosive gases and material, and so again, the volcanoes can either be a life giver or destroyer. So with abiogenesis, maybe it had a hand in the production of organic compounds or organic organisms, maybe extremophiles early on, and that's where we all come from. And it could also just wipe everything out too. So
Yeah, I mean it also might be responsible for clearing zones. We know like meadows and things like that are very important for different organisms to be able to get sun and
right,
evolve. So, but what's funny is all the like when you think of volcano because of the media and the way you brought up, you think of something like this, and that's the big bad
yeah, you think
killer.
of like a
Are these?
movie with like Pierce Brosnan on the run,
Yeah,
and every step he takes, there's a new lava flow.
right.
Something.
But I'm saying you think of these the mountains that are coming out of the earth, but what we've learned today is the real threats are the ones that are under the earth that we don't even see.
Right. Well, I mean, that's part of it for sure. I mean, so like, I don't know if it was the documentary I sent you or another one, but there's one where um, I forget the name of it. It's in Mexico, and the people live by there, and they know it's active, and they know it could go off at any time. And we'll talk about it on the next episode or the part of this series, and I'll get all the information on it. But the people um, that live near, they would rather live near the volcano knowing that it's active than not, from what I saw them talking about, because at least this is what was happening in Mexico. And the reason being is like, I don't know, it was just some weird thing, like it's like a cultural thing there where
Right.
uh they would rather have the notice of it, I guess, than, because there has been um and we'll have this on the other part too, but there has been like dormant or random things that have happened in their history that have caused them to think that way. So um, that'll be interesting to look into and talk about. But yeah, it's crazy. We live in a weird universe where nothing is really in our control, pretty much, except for our
Mm-hmm.
mind, and even then,
It,
you can't control that.
well, it seems like a lot of these ancient civilizations kind of just they respect the land and they respect that maybe it has something to do with psychedelics and stuff that's just whatever is going to happen, but I think that's a lot, a big problem with today's society. I believe that we're eternal beings, and when you have that, when you don't think that, you think everything's so finite, and then you can get caught up with all the worries of every day. But when you take in stuff, yeah, it might erupt and then something new will come from that, but there's nothing to really worry about. The worry is the worry itself. So
Oh.
a little
Um,
tidbit from Dr. Anxiety, ladies and gentlemen.
um, oh, and somebody just commented that the iron and the magma causing lightning and earthquake. So I don't know if you were here for that part, but I did mention that the newest study that the molten iron that got ejected from the southern Idaho super eruptions um, went towards magnetic north because it's obviously magnetic. So now, when a supervolcano happens, I guess from the pyroclastic flows and the volcanic ash in the sky, yes, there is scientific evidence that would cause intense lightning storms and stuff like that. So, um, but yeah, so that's pretty much it. for everybody listening, we haven't abandoned our ancient Greece series. I've been working on the Eleusinian Mysteries one. I just want to make sure that one's crisp and good. And that'll be episode.
Well, that was a good PowerPoint today. Very nice work, and
we'll do
some good information.
We'll do a part 2 on this, and we have an episode coming up tomorrow with our buddy Arthur, who runs the Secrets of the Norse page, and we're going to be discussing Norse and Viking mythology, and we're going to do 2 parts with him. We're going to do part 1 about the mythology, and part 2 will be about cataclysms and catastrophism, and linking, the stars to the ancient mythologies. And then sometime after that, we will get back into the Greek and do part 5 of the Greek, and we'll do part 2 of this. So, and we have.
Well, thanks everybody for tuning in. Hit that like button. Subscribe
Hit that like
if you
button.
haven't.
Yeah, subscribe. Leave us a nice review and 5-star on Apple Podcast and Spotify, and we appreciate you. We love all you, and stay safe out there. Peace.
Cheers.